All right, we're looking at A1.11, and we're getting into graphing linear equations and inequalities. So we're starting with linear equations. And I want to remind you of slope-intercept form, which is y equals mx plus b. So we're extending what we worked on the other day. Remind you that m stands for what? M stands for slope. Now let's take it. You said it's what? Rise over run. So that's important because we're going to use that with graphing. And what was that b value? That was the y-intercept. And so I'm going to add on to this. The y-intercept is going to be your starting point. So starting point on y-axis. That's important. So you can't do anything with slope until you have a starting point, and that's going to be on the y-axis. Now, number one is multiple choice, but I want to point out here, I would like you guys to think beside each one, put a little m equals and a little b equals. So yesterday we were pulling out the slope, and the slope is always paired with x. So my slope is 1/4, not 1/4 x, just 1/4. My y-intercept is always added on to the end. Do you see anything added on here? So what's my y-intercept really? Yeah, so I can put a little plus 0 there. So here's the deal. I'm going to go to 0, and that's my starting point. And if you look at the graphs, A is at 0, B starts at 0, C does not. So I can throw this one out because my y-intercept should be 0, and D starts at 0. Next, my slope, is it positive or negative? Positive. So my graph should be going uphill or downhill? So which one can I throw out? Will you shut my door? I should throw out D because this one is going downhill. C is also going downhill, but we already threw it out. Okay, so it's got to be one of these two, and you guys told me slope is rise over run. So this one goes up. Now look, do you see that we're counting by twos? Anyone catch that? Yeah. So if I go up 1, I'm right here, and then I go over 4, there it is. So I'm going to say it's A. If you went up to the block, you would go up 2 and over. You have to go over to 8 to get that 1/4. This one's backwards. This one has a rise of 4 and a run of 1. All right, so let's take a second. Notice this is already y equals mx plus b. What is my slope? Slope is paired with x, right? So slope is 3 or 3 over 1. And what's my y-intercept? 1. Okay, so if you look at graph A, it has a y-intercept of 1. So that works. Graph B, does it have a y-intercept of 1? No, so I'm going to throw that out. Graph C, does it have a y-intercept of positive 1? So I'm looking on the y-axis, I agree. How about graph D? Does it have a y-intercept of? So it's got to be graph A, right? Now let's just double check. It's a positive slope. Does it rise 3, 1, 2, 3, and run 1? Yes. So it happens to be graph A also. Now, I know that we could have done that quicker, but I wanted to sort of point out, hey, if it's a multiple choice question, we can eliminate some answers. All right. On the next side. Now, what's different about these problems, these graphs? They're shading. Okay, so it's still going to be y equals mx plus b. We still want to pull the slope and the y-intercept. So my slope is -4, and if you want -4 over 1, and what's my y-intercept? -5. Okay, so I'm going to start with that. A has a y-intercept of -5, so I'm keeping it. B has a y-intercept, not that. Do you see why they're trying to throw you off? Do you notice the x value is at -5? So as I was saying, this one's trying to trick you because it has the x value is -5, but we know it should be the y value. So I can throw out B. What else can I throw out? Anything else? This one's at -5, and is this one at -5? Yes. Okay, question. Should my line be dashed or solid? And why? Dash because it's not equal to. Do we agree with that? Now, all of these have dashed lines, so I can't throw that out. All right, so I've ruled out one of them by the y-intercept. Let's look at the slope. This one's going uphill, and my slope is -4. So I'm going to throw that out.
The explanation of that.
So this one's gone. We're looking for a slope at -4. Now, this one definitely has a negative slope. So if I start here, my problem is I'm going off the graph. So guys, instead of looking at my slope as -4 over +1, we can do 4 over -1. Do you agree with that? We can always flip it. So now if I go up 4, remember we're counting by 2. So here's 1, 2, 3, 4. I go over 1. That looks good.
C.
Well, but hold on. Look at D. It also has a y-intercept, and it goes up 1, 2, 3, 4, and over 1. So both of these graphs have the same dashed line. What's different? The shading. So let me rewrite this. Our inequality says y is greater than negative 4x minus 5.
So D.
It is D. Now, some people, you're not, but here's the thing. You're not looking left and right. You know, when we did the number lines before, less than went down the left, greater than went to the right. Well, you're saying the y value is greater than the line. Isn't the y the up and down axis? So the reason it's D is if you break this graph in half, the y's get bigger as you go up. So that's why we're shading the upper half of the line. So don't look left and right. You got to change it to up and down because we're comparing the y. Now, the other thing you can do, and I know some of you are ignoring me and moving on, but hold on. The other thing you can do is a test point. So the easiest test point to use is 0, 0. Does anybody remember doing that? And you plug in the test point. 0 is greater than negative 4 times 0 minus 5. 0 is greater than negative 5. Do we agree? That's a true statement. So if 0, 0 works, then everything works. If it was a false statement, I wouldn't shade the side that the point's on. It must be everything on the other side. Okay, I'm going to move over to the other side here. Now, first things first, this is greater than or equal to. We just talked about that. Should this be a dashed or solid line? It should be solid. So anything I can get rid of just based on that.
C.
I can get rid of C. So I don't even have to think about that because it's a dashed line. Okay, next thing. It's a pretty small inequality. It says y is greater than or equal to 5. What's M and what's B? Yeah, so what is the slope? So what would I put then? 0. Okay, so slope is always paired with x. Do we agree with that? Slope is always paired with x, and there's no x there. I could rewrite this inequality as y is greater than or equal to 0x plus 5. Now, you had said there is no slope, or there is none. I like to say this slope is 0 for the fact that people get no slope confused with undefined. When would my slope be undefined? Not on this line. Yeah, when it's x equals, when it's going up and down that x-axis. So the slope is 0. I rise 0, I run 1. Okay, my y-intercept is 5. It's that number alone. So slope is always paired with x. All right, so who has a y-intercept of 5? A and B. D does not have a y-intercept of 5. It has an x-intercept of negative 5. Okay, so if you read it again, it says y is greater than that. Here's my line. Y is greater as I go above. Do we agree? So it's not A, it is B. Okay, so I know that took a little longer to only do 4 problems, but I wanted to talk about why the graphs work and don't. All right, now we get into the real deal where we are going to graph. So with each of these things, I keep reminding you of y equals mx plus b. I would like you for each problem to pull the m equals and pull the b equals. Now, what's nice about all these problems, do you see they already say y equals? Well, except for that one. That one's a little bit different. But every other one says y equals. We don't have to solve for y. Remember someone brought up standard form before? Does anybody remember what standard form is? Standard form is ax plus by equals c. And if you have everything on one side, you have to move things around and solve for y. We don't have to do that. This is what we have. So on number 5, what's m? Negative 3. What's b?
1.
It's negative 1. Okay. Now, I'm always starting with the y-intercept. So I'm going to be on the y-axis at negative 1. Don't let that trick you. We're so used to doing x and then y. So the y-axis at negative 1, and I just have a slope of negative 3, but how could I write it? Negative 3 over 1. Okay. Should my graph be going uphill from left to right or downhill from left to right? Downhill because my slope is what? All right, so here's the deal. You get one negative direction. So if I start here and I go down 1, 2, 3, and these graphs count by ones, then I have to go right 1. And that's a mistake kids make. They go negative 3, negative 1. So I'm out of room. Now I could flip it. I can always reverse it. I can go up 1, 2, 3, and I can go left 1. Okay, Do the best you can to draw a straight line. Connect your points. If it really bothers you, there's rulers down in that bottom little bin by the door. And that's it. No shading because it's just an equal sign. Agreed? All right. Now, number 6 is different. We were just talking about this. You know how everything's all y equals on this page, and then you have this one that says x equals. This one has a slope that's undefined. This one does not have a y-intercept. It doesn't fit the rules. This one is your vertical line. Because no matter what happens, the x value is always at 4. So find where x is 4. And a lot of people just put a point there. They want to go back and forth. If I go up, aren't all these points 4, 1, 4, 3, 4, 5, 4, negative 4? Every point I hit on this vertical line, the x is always 4. That's it. These should be the easiest ones to graph, but they're the ones that we mess up the most because it's different. So anytime, think about it, it cuts through the x-axis at 4. That helps me remember it. So if x equals 4, remember that it cuts through the x-axis at 4. It's different because there's no y equals. All right. So go ahead. I would like you to graph 7 and 8. Pay attention to your signs. There's one thing I want to talk about. So when you look at number 7, it already is y equals. What is m and what is b? Well, the m says negative 4/3 like this. I would like you to put that negative sign either in the top or in the bottom because you need to get one negative direction. So if you have a negative number, you only get to use one negative. So I like to push it to the top so I don't lose it. The y-intercept is not 5. What is it? Negative 5. All right, take a second, graph those. All right, so we're starting here at negative 5. Now, my problem is I'm going off the graph, and I think a lot of you did too. So instead of doing negative 4 over 3, I'm going to do 4 over negative 3. You get one negative direction. So up 1, 2, 3, 4, and then left 1, 2, 3. And then sketch in your line. You can always make extra points. The big thing is you start on the y-axis because it's like your anchor point, and then from there you do your slope. All right, this one had a slope of negative 1 over 1. We can always put a 1 in there. And the y-intercept was negative 2. So on the y-axis, start at negative 2, down 1, right 1. So see how it's dropping. You have a negative 1 and then a positive 1. And then sketch in your graph. All right, any questions on those? Okay, now we're getting back into inequalities, yes? All right, I'm actually going to start with 10 first, and you probably can see 9 and figure out why. But I'm going to start with 10. First of all, should my line be dashed or solid? Solid because it is equal to. So I'm going to remind myself I need a solid line. My slope, I'm going to do negative 9 over 2. Like to get that negative sign somewhere so I don't lose it. My y-intercept is negative 4. Okay, so when I put my point at negative 4, I'm definitely not able to go down 9. So I'm going to go ahead and flip it. As long as one of my numbers negative, I'm good. So I'm going to go up 1, 2, 3, 4, another 5, and then left 2. So my line should be dropping. And now you guys told me solid line. And then we have to determine where to shade. Now, I would like you to be able to make it easy on yourself. So here's, if you can think about it this way, it's going to save you. Here is my vertical axis. And it is telling me that y is less than wherever the line is. So if you look at this as the y value, what y values are less than negative 4? Negative 5, negative 6 as I go down, right? So use your y-axis as your number line, not the x, and then cut this in half. Everything below the line is shaded. The other way to test this is to use a test point. If you don't like that shading method, the test point I'm going to use is 0, 0. I'm going up here. The y value is 0, negative halves times 0 for x minus 4. Is 0 less than or equal to negative 4? No. And guys, the reason I use 0, 0 is I don't have to do any math. 0 is never going to be less than negative 4. So if this point doesn't work, then nothing works, and it's got to be the other side. Okay, are we okay with the shading? Do you remember that? It shouldn't be a 50-50 guess. Think about it. The y is less than, it's going down. Y, it's going down the y-axis. All right, now this one doesn't even have a y anywhere, right? This one is going to be your vertical line. And what's the slope of every vertical line? There is, some people say no slope because it's not y equals. It's going to be the term of undefined. If it's undefined, you're remembering it's cutting through the x-axis at 2. What kind of line? Dashed or solid? Because it's not equal to. Okay, now read the inequality symbol. This one is talking about x being less than 2. So here's x is 2. What's less than if we go to the left? So everything down here gets shaded. All right, let's flip it over and knock these out. So go ahead and look at that first one and see what you want to do. Give you a minute. Go ahead and try these. Think about dash or solid, and don't forget to shade. You only shade when they're inequalities. There we go. You're supposed to do 11 and 12. All right, in number 11, it is going to be a dashed line. Did you catch that? Because it's not equal to. Slope is -9 or -9 over 1. Y-intercept is +4. So you have to remember, even though we talk about the slope first, we start at the y-intercept, and that is your starting point on the y-axis. Every y-intercept is an ordered pair. This one's 0, 4. Every y-intercept is going to be 0 and then that y value. Now, when I do my slope, I got to count out. So there's -4, -5, there's 9, and then +1. Look at your graph. Is it going downward? What? Dash line? And then did you get it going downward so we don't make the mistake of doing too many negatives? Okay, now this line's pretty steep, but it says y is greater. So if I'm here on the y-axis at 4, right, I'm shading up and to the right because y is getting bigger as I go above the line. Yes, so there you go. If you're having trouble with shading, see one of us individually or maybe your neighbor. If you use a test point, you would use 0, 0, and you would never get to use it if the line goes through it because we have to use above or below. If I did the test point of 0, 0, 0 is greater than -9 times 0 plus 4. Is 0 greater than 4? No. So if that doesn't work, then it's the other side. It's one or the other. Okay, in 12, what is your slope?
1/3.
+1/3. Okay, y-intercept? But what would we say then? 0. So we could put a 0 in there. It doesn't change anything. So start on 0, rise 1, run 3. So uphill, do we agree? Dashed or solid? Solid line because it can be equal. Are you putting arrows on your line to show that it extends indefinitely? And then which way should we shade this one? It says y is bigger than the line. So if you look at your y-axis, we would be going up. These are the y values that are bigger than our line. If I want to use a test point and I test 0, 0, it's going to say it's equal. I would have to use a test point like 0, 1. So if you're doing a test point, you're going to have to pick something that's not on the line. So I picked 0, 1. 1 is greater than or equal to 1/3 times 0. Yes, 1 is greater than or equal to 0, so it works. I shade. Okay, last couple. All I need to know is the slope. So slope we find by doing rise over what?
Run.
Rise over run. Okay, we start off with 13. I'm going to pick 2 points. They didn't give me any points. So here are my 2 points. You can pick any you want. What is my rise on 13? Do I go up at all to get over here? So I have a rise of 0 and a run of, in my case, 2. Don't leave me 0 over 1 or 0 over 5. You're going to make your slope just a 0. That's a horizontal line. Okay, 14, positive or negative slope? Negative. Now listen, you can't just pick any number you want. You got to make sure they're nice points. So I don't want to use something right here. I want to use something that hits a little cross arrow. I think these 2 points work. So you're telling me go down 1, 2, 3, 4, 5. Okay, I agree. And then over 1. So -5 over 1, or just simply -5. So these are not inequalities. We're just finding the slope. All right, go ahead. You do the next couple, and then we'll see if we agree. So you guys work, and then you can look up and see if you agree. Make sure you find nice points for them to cross. Show me the points you use like I did. So this one's pretty spread out, guys. So I went down 2, and then I went positive 7. So nothing to reduce there. Make sure you look for the nice points. You want to show what your points were. Do we agree? Negative 2 sevenths. Show me which points you used, because maybe you thought this point was nice, and I'm going to look at it and say, nope, it doesn't hit the crosshair. 16, positive or negative slope?
Wait, so why is it
positive or negative slope on 16? Positive. All right, let's find some nice points here. I'm going with this guy. I'm starting to go cross-eyed. Anyone else? Woo. All right, I'm going to rise 1, 2, 3. And I'm going to go over 1, 2, 3, 4, 5. So I do understand sometimes on these, I'll get a wrong answer because you thought maybe this was a nice point. That's why I'm asking you guys to show me what points you use and not just a random slope. Got it? All right, 2 more. 17. Well, if I go from this point to this point, what's my rise? 1. What's my run? Yeah, what is 1 over 0? No. Can I have 1 of nothing? No, so what's this one? Undefined. These should be the ones that you don't have to think about, don't have to work hard, but I'm telling you, 13, the one with the slope of 0, and 17 are the ones that we confuse the most or mess up. Guys, think about being on a treadmill. What's between going up the incline and down an incline is 0. This one, you can't walk up. It's undefined. So your final slope has to be cleaned up. All right, last one, positive or negative? 18? Aren't we dropping from left to right? Okay. It's going to be... No, you always read from left to right. So from left to right, we're going downhill. It's going to be negative. So it gave me points. It'll go down 1, 2, 3. And then I went over 3. Now you can't leave me that. Yesterday I had a lot of people leaving me things like this. What is negative 3 over negative or over 3? Negative 1. So we honestly could have gone down 1 and over 1, but they had those points there.